Hello, welcome again. We are solving Mechanical Engineering Paper 2 of year 2025 of Indian Foreign Services Mains Exam. Question number 7b. Calculate the terms of refrigeration required and the final relative humidity when the moist air enters a refrigeration coil at 40 degrees Celsius and 50% relative humidity at a rate of 120 meter cube per minute and leaves at 30 degrees Celsius. Now, if the surface temperature of the coil is set to 13 degrees Celsius and coil contact factor is 0.9. Work out the tons of refrigeration required and also find out the condensate flow rate. Assume barometric pressure as 1.01325 bar. Solve the problem using psychrometric chart. So here first condition is when the inlet temperature is 40 degrees Celsius and outlet temperature of air is your 30 degrees Celsius. And contact factor is given, that is 0.9. So contact factor definition is T in minus T out by T in minus T coil. And T in is your 40, T out is your 30. And from this T coil can be determined, that comes out as 28.88. Okay. So now we can locate the point 1 on psychrometric chart and T coil on psychrometric chart. So this is your psychrometric chart, and at 1 the condition is 40 degrees Celsius and 50% relative humidity. So if we see this psychrometric chart, then this is your 40 degrees Celsius and this is 50% relative humidity. So this is the point approximate. And here you can see the enthalpy is 100 degrees Celsius. And now another point is 28.8 coil temperature. So this is your 25, this is 29, 28.8 is about approximately 29. So this is the point. Okay. So this is the point. And now air leaving temperature is your 30. So now we can draw, we have marked 2 points on the psychrometric chart, this point and this point. We can join these 2 points and locate temperature 30 degree on this line. So the temperature 30 degrees is your this line. So it will be somewhere here. This. So here we have enthalpy approximately 90. Okay. And here we have this point. So relative humidity is about 90% more than 90%. That is, we can take it as 95%. So answer to first question is the relative humidity at 2 is just 95%, and enthalpy at 1 is 100 and enthalpy at 2 is 94. And tons of separation required are H1 minus H2 divided by 3.5 into mass flow rate. And mass flow volume flow rate is 120 meter cube per minute or 120 by 60 meter cube per second. And here the specific volume is 0.9. So tons of refrigeration comes out as 100 minus 94 into 120 by 60 by 0.9, that is divided by 3.5. That will be your 3.8 tons. Okay. So this is the answer to first question. You can see this on a small scale. So what we have done, we have found out this T coil temperature by using contact factor and inlet and outlet temperature, and then we located point 1 and this T coil temperature, and on this line we located point 2, and at point 2 the relative humidity was 95%, and at point 1 the enthalpy was 100 kilojoule per kilogram, and at 2 enthalpy was 94 kilojoule per kilogram, and volume at point specific volume is 0.9. So tons of refrigeration is H1 minus H2 divided into mass by 3.5. Mass is volume flow rate by specific volume. Volume flow rate will be in meter cube per second. Okay. So now putting these values, we can find out tons of refrigeration. So that is the answer to first question. So now when the temperature is changed to, then this so coil temperature is changed to 13 degrees Celsius, then there is a new T2 initial temperature is same but final temperature will be different. So we'll find out this T2 using the same formula. So T2 will come out as 15.7 degrees Celsius. Okay. So now there is different coil temperature, so T coil will be different. This point will be different. So this point is different. So this line will be different. So this is 13 degrees Celsius on cyclometric chart is approximately this one. Okay. And 15.7 will be somewhere here. So here the enthalpy is 42.5 and specific humidity is 0.010, and here at 40 degrees Celsius and 50% relative humidity the specific humidity is 0.023. Okay. So so these are the value. H1 is 100, H2 is 42.5, omega 1 is 0.023 and omega 2 is 0.010. So the equation required is mass H1 minus H2. So that is your 127.77 kilowatt. So this is your 120 by 0.9 by 60. This is your mass and this is your change in enthalpy. Similarly, this is in kilowatt, so we divide by 3.5, it will be done, that is 36.5. Same way, condensate flow rate can also be considered, that is omega 1 minus omega 2 into mass per second. So that is your 0.0288 kilogram per second.